Okay, so now we have the two constraint equations. This is one, and this is the second one, which is using our notation, n equals x plus y, right? So this was equation one, constraint one. And this is equation two. So I keep using the word constraint. Why is that? Well, because the two equations actually form two constraints. The first one is that the return must be equal to $7,000 or more if you're okay with using inequalities. And the second constraint is that there's only $100,000 to invest, right? So we have two equations, both of which are constrained equations. And the reason they're constrained is because if they weren't constrained, we could get any solution we wanted. But we want a solution that is subject to this real life constraint, so to speak, of, hey, I only got $100,000 to invest, and I want a return of at least $7,000. Those are real constraints. So in solving problems, what you have to do is to formulate the problem in a fashion that can be represented mathematically and is subject to real world constraints. So you're not finding just any solution, you're finding a particular solution for the particular case that you're examining. That's where the constraints come in. Right? I hope that part is clear. If not, again, post to the discussion board or email me, or we can set up a meeting and I'll go over this with you. But, understand this piece because this is important. The other thing that I want you to notice is that while we have written one of the constraints like this, and this doesn't look very much like this equation, it actually is basically the same thing. I could rewrite this equation like so, right? Where the value of P is equal to 1 and the value of Q is equal to 1. So really, this isn't any big deal. I have one other point to make about this question, but let's cover one other piece that I want to show you so that there's no confusion. Let's look at, here's another graph, and maybe I'll share that link with you as well. Here's the thing to note. This equation, if you see this equation, right, this is written in exactly the same form as this equation, right? You can see that, right? Compare the two, right? Sx plus my equal d, and here is ax plus by equal m. Well, I mean, I can move the variables around to, or move the coefficients around to write the equation like this, right? Then I can further redefine the variables to make it look like this equation that we started talking about way back when, the equation of a straight line, right? And to convince you that these are exactly the same, let me turn on these equations of the plots anyway. You see the dotted line? I mean, without this, this is the solid red line here. If I plot the equation in this form, it's the dotted green line, and then the sort of generic equation is the dashed purple line, and I can turn this off so you can see this, right? They're all the same, and you can see that because as I move these values for A and B around, right? Nothing changes, right? All the three equations remain right on top of each other because all three equations are actually the same equation, just written in slightly different forms. Now, I don't want you to be confused by this negative sign here because there's no negative sign in front of the m. It looks like this because look, the value of A here is -1, -1. And that, if you plug in -1 here, the two minuses multiply together and become a plus thing. So that's a plus m. So the slope equals, with a -1 here for A, the slope becomes equal to plus 1 over B or plus A over B is the way that's going to work out. So it's still true that a positive value for the slope, if A and B are both positive numbers, the slope is going to be negative, right? It's going to, let me just move this over. So A is positive here, B is positive here. So A over B is positive, but the slope as defined as A divided by B with a minus sign in front is negative. So the slope is negative. Yeah. Yes, of course it's negative. It's going down like this, right? And when I change the value of A to become negative over here, the minus signs cancel because A is negative, the minus signs cancel, and so you get an overall positive value. And yeah, indeed, the slope is positive. It's going from the bottom left to the top right. So I hope that part is clear and is not causing any confusion, right? This form of the equation and this form of the equation and this form of the equation are completely identical, right? And if you're using the coefficients as defined over here and sort of consistently write out the equations in these three forms, you will not have any problem. So this is just an aside that I wanted you to be aware of and not get confused by the form of the equation. This is also the general form of an equation, straight line, right? As is this, right? They look very different, but they're exactly the same thing, okay? Now there's one other thing that I want to emphasize, and which is this, because it can prevent you from going astray or making mistakes. In the equations, whether it's written in this form or written in this form, the units on both sides of the equation need to be the same. What do I mean by units? Okay, this is a simple one, so let's just talk about it. Here, X is the amount to invest in the first investment, and Y is the amount to invest in the second investment. What are the units of investments? Money, right? Dollars in this case, if you're living here, euros or rupees or what have you, whatever the local currency is called. But the point is that the units are in money. And it's important for an equation to be correct, for it to be an equation here, or an inequality for that matter. The units on both sides of the equation must be the same. So you have $X here, $Y here. These are not coefficients, these are not multipliers. I'm simply, showing you that this is money. $N here, money, 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 dollar, dollar, dollar on all sides, okay? And ditto the case over here. X is in dollars, $X, $Y, and $D, right? What about this S and M? S is the interest rate, right? What is the interest rate? Okay, it's where can I write this out? Interest rate. Interest rate. So focus on this word rate, right? What is rate? Rate is how quickly or slowly something changes, right? Interest is simply what you're earning on a given investment, right? And so interest rate means how much you earn on that investment in a given length of time, right? Typically, and this has been an unstated assumption, that we have been expressing interest rate here in terms of the number of, more on this in a moment. in terms of 1 year, right? So what is the return that you get in 1 year? That has been an unstated but implicit assumption throughout all of this discussion. But an interest rate may be quoted at a rate different than 1 year. Could be per quarter, per 6 months, per week, whatever, right? But so here we have just been using per year as a matter of convenience. So M times, so we can follow this through the calculations in the following manner. The rate, as I mentioned earlier, is per year. Okay, and percentage, we talked about that. So the interest rate is 0.10% per year, right? So if you multiply the interest rate by the amount invested, which is in dollars, 0.1% or 10% per year is 0.1 per year times the amount of dollars gives you the number of dollars per year. Now, as I said earlier, we have sort of wiped out this consideration of the year simply because we have assumed everything is going to be happening over the course of 1 year. But regardless, the point that I want you to notice is that the units are exactly the same on both sides of the equation. It's, dollars, dollars, dollars. If you were to have year, it would be dollars per year here, dollars per year here, and then of course we said $7,000 is what Blondie and Dag would expect to receive per year, right? So the units are consistent. This is way, way more easy to see in this equation where it's the amount invested in dollars. If you look at this equation and do this analysis, if the units are not consistent on both sides of the equation, there is a mistake in the equation, right? So it's really important for you to make sure that the units on both sides of the equation, that is whatever you're using, it's dollars here, it could be weight in pounds a kilogram, it could be time itself on years or days or months, whatever units of time you're using, or indeed it could be anything else. If you're doing dosage calculations, it could be milliliters and so forth. Whatever the units happen to be, you must have the same units on both sides of the equation. That is really important. Otherwise, there's a mistake in the equation, or in the way the equation was the problem was conceptualized and formulated. By the way, another important element to note is that as I mentioned, the rate is the change over a period of time, but it doesn't have to be time. The rate is change of something with respect to something else, right? It could be, like here, dollars per unit time. It could be pounds per unit time. It could be dollars per pound. You've gone to the grocery store or the co-op or someplace, and you've been able to buy grapes at, I don't know, whatever they're going for these days, $1.50, $2, $3 per pound, right? So that $3 per pound or $2 per pound is the rate at which grapes can be purchased. The price is when you multiply or cost, if you want to use that word here, the quantity of grapes you buy by their rate or price per pound, right? That'll give you the total cost that you have to pay, right? But it's important to note that the per pound rate is just that, a rate. If you go to a grocery store and you look at the labels for the various products on the shelves, not so much on the produce section, you will notice that they give you the per unit weight. It may be ounces, it may be pounds, or whatever rate on the little sticker labels that tell you what product is sitting on the shelf. So look they're about an inch high and about a couple of inches wide, those labels, and maybe yellow or white backgrounds. So read those closely and you will see the a unit rate that is based on price per pounds, and that's so you can compare the what you're paying, the real cost that you're bearing for two different products at the same time. So, for instance, two different brands of peanut butter or jelly or flour or tea or what have you. Now, having talked about rate as being the change of one variable with respect to another variable, here is one more thing to note, or rather, two more things to note. Let's take the easier one first. You'll notice that in this equation, the units are dollars throughout, money throughout, right? But in this equation, if we use this formulation of rate as something changing per year, the units work out to be dollars per year, right? This is $7,000 per year that you earn. Here is the interest rate in terms of return per year. And then this is the number of dollars invested. So both sides have the units of dollars per year. In this equation, both sides have the units dollar. So your two equations don't have to have the same units, but in each equation, the same units must be present on both sides of the equation. Okay, that's important. The other piece to think about is that this portion, right, the interest or the magnitude of that when given as a percentage, this is a unitless quantity, right? First of all, it's a proportion. A proportion or a percentage doesn't have units, right? Even if there was something to have units, if you wrote it like this, 10, I'm making this up, right? So let's say if you had $10 per, oops, that's not how it goes, $100 or $1,000, okay? The dollar in the numerator here and the dollar in the denominator here cancel out, right? So the magnitude of the rate here is the percentage here is dimensionless. It does not have units, which is why you're able to write 0. Well, I've got to undo the strikeout bit. Okay. 0.1 per year, and then this whole quantity multiplied by star dollars to equal, I'm just going to write this dollar per year, right? Per year. So right, we have this, and then if what were we using? $60,000. So let me write it like this: 60,000 is equal to, then works out to be 6,000, right? So they per year, right, from this portion, okay, comes here, right? Right. And the dollar from this portion, let me just change the highlighter color. Oh, well, green goes with money, I guess. Here, right? So that's how you get dollars here and per year, because this is unitless, right? There's no units, but the rate is per year. So you got the year here and the dollar here, and then you end up with dollar per year on the right-hand side. I hope this is clear. This is important because not keeping track of things like this basically causes you to make errors, right? So if you check your work as you go and make sure that the units are balancing, you'll be better off, right? I don't know if you'll be fine depending on what else is happening, but you'll at least be better off.